Hey again, everybody. I thought I'd do a couple of just sort of random Taylor-Maclaurin series type examples. So the first one I'm going to do is the function is 1 over x squared, and they're asking for a Taylor series centered at 1. Okay? So my Taylor series centered at 1 to represent this function. So in general, my Taylor series would be the nth derivative evaluated at a times x minus a to the n over n factorial. That is our generic sort of Taylor series setup. And we know a is 1, so we can at least simplify that part. So this is the nth derivative at 1, x minus 1 to the n over n factorial. And then, like all the other ones, we really are focusing in on what that is. Now, this is not one of the core 4. So I don't really have, I don't have a trick for this one. I can't just plug in x squared and hope for the best. I need to still figure it out. Okay? So here are my nth derivatives. Here are my nth derivatives evaluated at 1, right? Because again, we're centering at 1. Let's do a few and see if we can't find a pattern. And if there's no pattern, well, then we'll just have to list out the terms. So our derivative, let's see, this is x to the negative 2. So this is going to be x to the negative 2, negative 2x to the negative 3, positive 3 times 2x to the negative 4, negative 4 times 3 times 2x to the negative 5, positive 5 times 4 times 3 times 2x to the negative 6. Okay, if I plug in 1, I get 1, negative 2, 3 times 2, 4 times 3 times 2, negative, sorry, and then positive 5 times 4 times 3 times 2. So what's happening here is I'm definitely alternating positive, negative, positive, negative, positive, right? So I have to deal with that. So I have negative 1, and I'm starting positive, so just to the n. But I also have, I have factorials, but it's kind of like weird. Like 0 factorial is 1, that's fine, but 1 factorial is not 2. 2 factorial is not 3 times 2. So it seems like whatever n value I'm using, my factorial is like 1 up from that, right? So this is really going to be n plus 1 factorial. N plus 1 factorial. Let's try it. If I put in 0, I get 1 factorial. Okay, no big deal. If I put in 1, I get 2 factorial. I put in 2, I get 3 factorial. I put in 3, I get 4 factorial, etc., etc. So this is going to be n plus 1 factorial, and that takes care of that. The x minus 1 to the n comes along for the ride. That's part of the formula. Over n factorial, that comes along for the ride. And I can simplify this a little bit because n plus 1 factorial over n factorial, that's just n plus 1. So I have negative 1n to the n plus 1, x minus 1 to the n. And this is 1 over x squared, Taylor series centered at 1 for 1 over x squared. If I were to list out this term by term and center this around 1, I will get a polynomial that represents 1 over x squared. Okay? So looking at this Taylor series, we can also find its interval of convergence. Okay? With our Maclaurin series that we had an interval of convergence that seemed to work all the time, except for geometric. That was just between negative 1 and 1. But let's look at this particular example and answer that question. We would expect around 1 this to be good, right? If it's centered at 1, we would expect 1 to be perfect, actually. But we can just do a quick little ratio test, make sure everybody's on the up and up here. So absolute value, negative 1 to the n plus 1, n plus 2, x minus 1 to the n plus 1, over negative 1 to the n plus 1, x minus 1 to the n. All right, so I put in n plus 1 wherever I saw n for the numerator, and the denominator stayed the same. The absolute value is going to take care of this. It doesn't really matter. Even though I do have a negative 1 here, absolute value is going to take care of it. And what do I actually have left? I've got n plus 2 over n plus 1. And x, what is that? X minus 1. I have an extra x minus 1 term. Well, as n goes to infinity, that goes to 1. So this becomes absolute value x minus 1, which I need to be less than 1, which means x minus 1 is between 1 and negative 1. which means x is between 2 and 0. So my interval of convergence is 0 to 2, and I'm going to exclude them because if I put in 0 for x, what do I get here? As n goes to infinity, that's just going to go off to infinity. If I put in 2, I'm going to get the same thing, and it's still going on, because the n plus 1 being in the numerator is not helping this situation. Okay, so I'm not including 0 and 2. Okay, so this one does have a little bit of a restriction, but we used our Taylor series formula to figure it out. Okay, we got the series, we got the interval of convergence, and I think that's pretty much everything we would need to do with something like that. Okay, so just sort of a generic example. Hopefully this just gives you a better insight as to how this all works. Again, they're not always going to be core 4 problems. This is not a core 4 problem, but we just, we'll just have to figure them all out as they come. Okay, let me know if you have any questions, and I will see you guys later. Peace.